Welcome back. So, in last lecture, this was the slide we stopped, and we were talking about the meandering rivers. So, let us see a few more examples and associated landforms related to the meanders. So, this also part we have already discussed. So, let us move ahead. So, meandering dynamics mainly as I explained that if you look at the outer edge, then you will find that it is deeper and the currents are more velocity is higher here, whereas on this side, that is the inner part, it will be more or less and the depth will also be less compared to that. Okay. So, if we look at this field photograph, then you will see that there is this river has, or the pattern channel pattern is having a dynamics which keeps on migrating, and it will migrate in this direction, okay, usually because there is an erosive bank or the erosive nature of the channel here. So, it will migrate here, and as well as it will keep depositing here. Okay. So, it will move in this direction. So, few more things. This is what we were talking about. This is in point bar here. So, this will be your point bar, and this part will be termed as talvage, which is the area of maximum slope and greater energy. So, the velocity in this area will be much higher, and that is one of the reason that it has an erosive nature. Okay. Now, coming to the part of the development of oxbow lakes, or we also term this as an cutoff banks. So, it is a simple mechanism here, or we can say the process. In fact, okay, what we see here is that this is an erosive nature of the bank, and the river is flowing in this direction here, and this part is also having an erosive nature. And as I mentioned in previous slide, that this will move or migrate in this direction. Okay. So, the time will come when this channel will join this one here, and this portion will be left out. Okay. And that is what we call cutoff channels. And these are very commonly seen if you look at the Indo-Gangetic plain. You will be able to see this type of cutoff channels remnants. So, this is another example which shows so earlier the channel used to flow like this here, and then this got connected here. So, the next phase, this will be the area where you will see the connection, and this will be the left out cutoff bank. So, again along with the erosion and deposition, what we see here is that the portion of mostly the straight channels what we are having. So, within the meander what we are having, this is a meander here, but within that some portion you will come across they are straight. Okay. So, what type of sediments? The blue, dark blue is showing the energy conditions are higher here. In this case, the meander, the energy condition is higher here, similarly here also. So, this is showing the velocity here, high, medium and low. So, mostly you will find that in the meandering part you will have this component also, that is low, whereas in the straight you will have mostly the medium and this one. So, along with that, what you will find is that the deposited material, okay, will vary from place to place depending on the pattern of the channel. So, here you will see mostly the coarser deposits, whereas in the case of the meander you will have mostly you will see all. Okay. So, that is coarser will be on the area where you are having high energy conditions, and finer and medium will be in the area where you are having medium to low energy conditions. So this is a mechanism which has been explained, or the process which shows that if as soon as the channels start winding up, and that is your meandering is getting more sinus in the sense, then this is the last stage where you will see an cutoff channel, which is also termed as oxbow legs, okay, because it's in like shape of the oxbow, and that is the reason why it has been termed as oxbow leg. So you just have to remember that what is the process which is happening here, and before what was what we were able to see. Okay. So I'll show you a couple of examples, because while selecting the sites for any construction, so suppose you are having a meander here, and you have been asked to put the bridge here, or you need to put the bridge. So you should not put the bridge across such areas, because it will have a tendency to change the path, okay, and that is the migration, and because of the processes which we have just seen. Okay. So creation of oxbow leg, this is another example which has been shown, so you can go through this. So this is again the same process which we were talking about. This is the first stage, then this comes nearer to each other, then finally what we see is that this is connected and this is left out, which we see an oxbow leg or cutoff channel. So this has also been termed as cutoff channels. Now there is an example where we are having, like we are at Kanpur, and there is an excellent example of a very large meander loop which has been left out long back. So close up of that, if you see, it has been shown here. Okay. So this is the portion of the, and research carried out on this suggests that this cutoff bank, which is quite large, okay, if you can see the scale here, then it is quite large. So this is not very old, it is hardly within 10,000 years. Okay. Now coming to this is another close up of that. You can see this cutoff here, and there are many other cutoff. I'll show in the coming slides. Okay. So this is the close up of that one here. So earlier the channel used to flow through this path. So the reason here is that, for example, this is an house sitting on the erosive bank of the meander. This is an example from Washington. So what happens next actually? Okay. So this is the case what you will find. Okay. So this banks, and that what we have discussed in the beginning of this lecture, that during the floods or peak floods, this type of cases were observed in Uttarkashi and all that. Okay. And that was mainly due to the erosive nature of the channel, which eroded the banks, and now this house is sitting just about to collapse here. Okay. So earlier they had in this much of area of the river bank. Okay. But now this is completely eroded. This portion is completely gone. Okay. So that's what you see here. Okay. So these are the areas of concern where we need to be very careful. Now this is one of the example which I always discuss with my students, that if you are having if you are given this area and then you have been asked to put in bridge, of course there is a bridge which is connecting here. There is a road here which connects and goes through Hamirpur. This is a town here, a small town, and it moves further ahead. Okay. Now what will happen in future if you consider what we have discussed now? Okay. So this is a close up here, and as we have been discussing in previous couple of slides, that this portion is having so this is an outer portion of channel, and it has an erosive nature, and it also tends to migrate, okay, or you can say shift. So, shifting will be in this direction. So, the time will come that this channel will keep on migrating here and will join this one. Okay. So, this will be left out portion. Now, the only point is that in that case there was again there is no need for this bridge over here, okay, because this will be disconnected, this channel. Okay. So, given an example to interpret, then you can give your suggestions that what will happen in such cases. Okay. So, this is the close up of that. Okay, that area, that is Hamirpur. So, probably this town is in danger, we can say, okay, because it definitely this will keep eroding, and this channel, you cannot fight the nature, it will keep moving here this side. Okay. So, another one is your braided streams, which have like multiple channels connecting further downstream with the main channel. So, braided streams are depositional channels, divides into a series of braids separated by your islands, that is your braid bars, or you can say braided islands. Okay. So, braided channels forms, the conditions are streams energy is high, the channel gradient is steep. So, these are the main point, the energy is high, gradient is steeper, then sediment supply is high here, okay, with coarser bed load supplied from the hill slope and tributaries, and bank material is erodible, allowing the channel to shift sideways. So, this will be not very deep channels mainly, but you will see that these channels have a tendency to migrate. Okay. So, this is another issues with the braided channels. Another similar to braided channel, which we term this as an anastomosing channels. Okay. So, anastomosing channels have a set of distributaries that branch and rejoins, again very much similar to the braided one. It mimics the braided channels, but braided channels are single channels form where the flow is diverted around the obstacle, that is obstacle like you are having a bar here. So, the braided channel will flow like this, and it will be having single channel. So, for example, the channel is coming from here, then this will bifurcate like this, and if you are having another bar here, then it will go like that. Okay. So, this is typical of braided channel, but this will have multiple channels. Okay. And it as I told that it will mimic, it is very much similar to what we call, not the same, but similar to your braided channels. Okay. So, anastomosing channels are set of interconnected channels separated by bedrock and stable alluvium. Alluvium is basically the loose material. Okay. So, this again have a tendency to migrate very in the wide areas. Okay. So, this again and issues with the anastomosing channels. So, if you know the pattern of channels you have identified, and then you have to give your suggestions for the best site selections, then you need to understand and the different patterns of the that reverse, so that is the channel patterns. Okay. So, this is an example of the braid bar. Now, as I told that if you look at into the Gangetic plain, this is a Corona satellite photograph of Gangetic plain. So, what you see here is multiple things. Okay. So, one we see here is the main channel, which is the present day stream or the channel, and then few we can see here the cutoffs. Okay. So, these are you are having the cutoff channels here, and there are few here also. Okay, on this side. So, and this whole area. So, because we, as we have learned and discussed in the beginning of the lecture, that the reflectance or the objects we can differentiate based on the reflections what we are getting back. Okay. So, this is on the, we can say this is because this is a panchromatic image. So, we see and a variation of the gray tone here. Okay. So, what you see here is that, let us look at further in detail. So, this is your main channel, that is your active channel, and this is your older meander, and this boundary which is marked between the darker one and the lighter one in the gray shade is your active floodplain. Okay. So, river, as we were talking about, that this channel pattern has a tendency to migrate or shift. So, within this active channel we should not allow any construction also, because this will have a tendency to occupy, or we can say reoccupy the same its own channel also. Mostly this is common when we look at the alluvial fan areas, which we will be discussing very soon, but this also channels have the tendency to do that. The darker parts what you see here are the older alluvium, or we can say the older floodplains. Okay. Even in coming slides we will talk about, and this will be on the a little bit higher as compared to this one. Okay. So, if you put in cross section here, then what you will come across is something like this. Okay. So, if I put, so this will be your active channel, this is your active channel, and these are older floodplains. Okay. So, as I told that you can look at any Google image, you will be able to see this features. Okay. You can see here also you have a meander, older meander which has been sitting, and as we talked about this one and this one here. Now, river and river related landforms, as we have discussed, as one is in the beginning we were talking about the levees also. So, naturally the levees will be like, as I have discussed in the beginning also, that it will be slightly having a slope towards the that is away from the main channel. Okay. So, it will be having the slope on this side. So, and to protect this area in particularly, artificial levees are also been constructed. Okay. So that the flood waters doesn't enter this areas, and this areas will be used for construction and all that, or maybe for agricultural purposes. So, there are like examples where artificial levees have been put. So, considering that this will be this level will be the maximum flow depth here, it can go up to this also, but this will not cross this. Okay. So, protecting the surrounding, that is the floodplain areas, you will see that. So, this is the area, this sketch, it shows that the river is flowing in this area where you have the active channel, and during the flood events this whole area will be affected. But if you are putting the levees, that is landscape after the construction of levees, what you can do, what you have done is that you have channelized the flow. And another term which has been commonly used for this is your river training. So, river has been trained to flow through this path only. Okay. And then you can use this for, so this is what we are looking at, is that if you take the cross section, then you will find that this is something like this. Okay. So, this part is elevated here. So, channel the river has been trained to flow through this artificially, okay, and the flow has been channelized through this. So, this can be used for construction, and for the agricultural purposes. So, when there is a low flow, you can say then this portion also will be used for the agricultural purposes. So, riverside you will find that most of the during the winter and summer, before the rainfall and before the channel is getting into the flooding state, this areas are being used for agricultural purposes. So, what we are expecting from you is that when you are given some exercise to map the geomorphic features, you can talk about all this. Okay. So, advantage of natural levees, another example, unless and until it has been breached, then this area will get flooded, but mostly you will see that this areas are been protected. So, you can see now the clear cut profile of the cross section profile of the artificial levees and which has been constructed and which shows that the channel has been trained to flow through this pathway. Another landform which is common in the fluvial regime is the alluvial fan, and the final destination where the river goes and meet, that is the ocean, then you will see the delta. Okay. So, we will see these two examples quickly. So, mostly when why the alluvial fans are formed, again when a stream flowing through a steep slope. Okay. So, we are talking about the uplands here, steep slope. So, if you say that this is the profile here and then these are the hills. Okay. So, when the stream is flowing through steep slope and suddenly it enters into the, so in this area it will remain confined. Okay. So, we can say that the flow is confined in the upland, whereas in the plain areas, that is the alluvial plains, the flow will be unconfined. So, basically I will explain here. So, you are having a slope here. So, in this portion, like in the uplands, it will be confined, but here it is getting unconfined. Okay. And again there is a change in the gradient, sudden change in the gradient. So, that what we will see here. So, one is that the flowing through the steep slope, steep valleys in the upland areas debouches suddenly onto a nearly flat. So, for example, if you consider this as an Himalaya and this as an Indo-Gangetic plain. Okay. So, you will find this very clear demarcated geomorphic landforms along the foothills. Okay. So, it is entering into the flat area, that is your alluvial plain. It experiences decrease in slope. So, there is sudden decrease in the slope here, okay. A corresponding drop in the velocity, okay, and a decrease in its ability to carry the sediments. So, the carrying capacity also you can say reduces. So, carrying capacity also decreases here. As a result, the stream deposits its load in a fan like shape, because it is getting unconfined. So, it will just deposit or unload the material, and this fan shape, that is the reason, because the material which is loose material has been termed as alluvium. So, and we call this as an alluvial fan. So, that is how this term has been given to this landform. Okay. So, these are the examples, as I told, that you will be able to see this commonly at the foothills of mostly the hilly terrain, where you are having the confined streams coming from the steeper slope, and this is the gradient drops here. So, it will become unconfined and the deposition will be. So, it will have multiple channels here. Okay. Again, so this is an example from the the foothills of Himalaya, where you are having the sub-Himalayas, or we can say this Shivalik hills, and this is the area from Chandigarh where you are having the major fan deposit. Okay. So, there is a fan which has been deposited over here. Now, issues with the alluvial fan is that if you have to select the sites and all that, and if the channel is active and have the capability to deposit the fan again, because there are gradational phases which we have come across in the studies in many locations, that the fan aggradation are seen in the multiple sequences. Okay. So, the area close to this will be of high hazard, and in middle part it will be moderate hazard, and the lower hazard as you move away from the fan. Okay. The reason here is that you have you will have the coarser deposits here, and as you move, so this will be like medium in size and this will be finer. So, as you move from the proximal end to distal end, this is your proximal part, that is exactly we can say this one is will proximal, and this will be your distal part. Okay. So, if you move from proximal to distal, then you will find there is a change in the grain size from coarser to finer, and that is why the hazard has been marked here, that close to the proximal part you will have higher hazard. Okay. So, we will stop here and continue in the next lecture. Thank you so much.